Hey guys, welcome back to Genius Learning. All right, continuing the series, we have a building, and you may be wondering, this building is polka dots. I messed up, and so I thought it'd be cool. It's kind of weird. So we got a polka dot building, right? It's 265 meters tall, so that's the displacement in the Y that's given to us. And for some reason, somebody throws or just drops, really doesn't have any movement in the horizontal, drops an iPhone and it cracks, right? What time does it take to land on the floor, knowing that the building is 265 meters tall? So only with that information, we want to know how long this took. All right, so now let's start off with things that we think we know. All right, so let's write some formulas down. All right, let's write. So we need to know the time final. Okay, we have the displacement in the Y, so let's start there. Let's write the displacement in the Y is equal to velocity initial in the Y times time minus 1/2 gt squared. Okay, so we have that. Let's see what else we can do. We need a time final. Maybe we can also write, I'll write it here. So maybe we can also write velocity final in the Y is equal to velocity initial in the Y minus gt. Why write it? I don't know, but maybe it could be helpful right now. So we know that one of these velocities has got to be zero, right? Either we start at zero and then throw it, or right when it hits and cracks the screen like that and breaks, the velocity is zero. Okay, so I think that we'll go with that one. So right when it hits, velocity final is equal to zero. So we can start there. Okay, so doing that, making this part velocity final equal to zero, make that zero. We're going to only have this side left. So we have 0 is equal to velocity initial in the Y minus gt. This might have been a little confusing, so I'm just going to scratch this out. Okay, so this was just saying this is 0, like I did here. Okay, so velocity final, when the phone splatters, it cracks, whatever, is 0. And velocity initial in the Y minus gt is left. So I'm going to move the velocity y over. You're going to get negative velocity initial in the y minus gravity times time. Cancel out the negative sign and bring over the g. We got velocity initial in the y, ugly y, over g. Okay, equals time. So now we have an expression for time, right? We don't have our velocity initial in the y, and we know g, so we have this expression. Okay, maybe we can do something with it in this equation now. Okay, so now let's take this, travel that way, and take a look at what we have there. We know this already, right? 265, that's our displacement in the y. Velocity initial y, we don't know. Time, we don't know. Gravity, we know. Okay, so let's plug in the value of t into the equation and see what we get. So we got, I'm going to write 265 here already. So 265 is equal to velocity initial. Where the t is at, I'm going to put this. So velocity initial in the y over gravity minus 1/2 g. And when you have the t, I'm going to put velocity initial over gravity squared. Okay, so this part now is algebra. A lot of people mess up this part, and I'm telling you, don't mess up on the algebra part, because it's the easiest part, but it could be the trickiest if you're not ready. So let's get ready here. We're gonna put these two together. All right, so I'm gonna rewrite this 265. Here we have velocity initial in the y squared over g from this two terms. And here you got 1 g on top, you got 2 on the bottom. So this one's gonna cancel out, and this one's gonna be left with 1 on the bottom. So let's do that first. We got minus 1 over 2g, right? The 2 stays, and you're left with 1g on the bottom because there was 2 from the squared, then there was 1 up here, boom, boom. So we're good, and we're left with velocity initial in the y squared, okay? Now, for this next part, I like to do it separate so it's clear. Okay, you got velocity initial in the y squared over gravity, velocity initial in the y squared over gravity, right? What is left outside of that, right? So, or if we take out velocity initial, let's do that. So algebraically, we're gonna, from these two terms, we're gonna take out velocity initial in the y squared over gravity because they both have those terms. I'm gonna put a parentheses, and so if from this term, if I take out velocity initial squared over g, what am I gonna be left with? Just a 1, okay, minus, and if I take out velocity initial in the y squared over g, all I'm gonna be left with is 1/2, okay? So if I distribute this back into this one, I'll get this term. If I distribute this back into this term, I'll get this one. Right, so just a little bit of algebra. And now let's put these together. So that's 2, 2, so this is 1/2. Right, so we're gonna get a 1/2 from all that. And I'm gonna put it all together now. So I'm gonna put 265 is equal to velocity initial in the y squared over 2 times gravity, right? Because the 1/2 is up here, really. And so the 2 and the g multiply with each other. So now I just rewrote this with the 1/2 down here. Okay, so now we're looking a lot better. We know everything except for velocity initial in the y. So let's solve for that. We're gonna put the 2 on this side, multiply it, put the gravity on that side, and 2 gravity 265, let's put some parentheses here. And then we got velocity initial squared. Square root it, so we're gonna square root, we got 2, we got 9.8 for gravity, and we got 265, and that is gonna be our velocity initial in the y. So, did I calculate this? Yes. Velocity initial in the y is, okay, velocity initial in the y is gonna be 72.07 meters per second. Okay, so what was the question? The question was, what's the time final? Okay, well, we found something, and now we can use that velocity initial in the y for the first equation that we set up with the ugly y there. So we're gonna go back here, plug it in now, and get our time final. So velocity initial in the y up here, which is 72.07 over gravity, which is 9.8, is equal to, we got 7.35 seconds is the time final where the iPhone drops from the building and whoever did it gets clout and is happy about what he just did. 7.35 seconds, initial velocity in the y, so this is how fast it was released. Maybe it was released from a higher place or whatever, but from this point, the 265, it's already traveling this fast. Okay, then when it gets to the bottom, velocity final in the y. This is important because think about it, one of these two have to be 0. So if you can think about that, then you can think about making this 0. You can think about solving for an equation, making a system of equations, and making things work, okay? So hopefully it was helpful. Let's continue the series.